We now turn to a different subject, using moles and formula weights and doing actual calculations. We'll do this by looking at a lecture problem. Calculate the following quantities: the mass in grams of 0.105 moles of sucrose with this formula, the moles of zinc nitrate, 143.5 grams of the substance, the number of molecules in 1 times 10 to the negative 6 moles of ethanol, and the number of nitrogen atoms in 0.41 moles of NH3. I'll go ahead and show you how to do some of these by looking at the doc cam. To convert 0.105 moles of sucrose, which has this formula, into grams of sucrose, we first of all need to get sucrose's molecular weight. Let's go ahead and write out its formula here. We should remember that each carbon atom weighs 12, and there are 12 of them, so I'll write 12 times 12. Each hydrogen atom weighs 1, and there are 22 of them, so I'll write 1 times 22. And each oxygen atom weighs 16, and there are 11 of them, so I'll write 16 times 11. 12 times 12 is 144. 1 times 22 is 22. 16 times 11 is 176. If I add all of these guys up, I end up getting a total molecular weight of 342. You'll remember that I told you in an earlier video, or maybe in the same video, I honestly am losing track, that the units for molecular weight are grams per mole. Why is that so important? It's important so that you can do problems like this. Here's what I've got: 0.105 moles of sucrose. I want to turn it into grams of sucrose. How do I do that? Unit analysis. Here's my bracket set up. I'll go ahead and put moles in the denominator. Now you should remember, of course, we put the units in the denominator that we have of the set of brackets to the right that we have in the numerator just to the left. So that's kind of how it lines up, because they'll cancel each other out. What am I going to put in the numerator units-wise? Well, I'm going to put grams. And why is that relevant, grams per mole? Because this set of brackets is the molecular weight. You throw 342 on top, the moles cancel each other out, and I'm left with units of grams. Plug that into a calculator, and that is the correct answer to this question. Here I've got 1.0 times 10 to the negative 6th moles of this substance, which happens to be ethanol. I'm trying to turn it into molecules. How do I do that? Well, of course, I'm going to use a set of brackets. I'll write units here in the denominator. What will those units be? Well, they have to match the units in the numerator to the left, so it's going to be moles so that they will cancel each other out. Can I directly relate moles to molecules? If I have 1 mole, do I have a certain number of molecules? Always, always, always? Yeah, I do. That is Avogadro's number. 1 mole is always equal to 6.022 times 10 to the 23rd molecules. I really wish I would have made this bigger. Anyway, the moles cancel out here in the basement with the moles up here in the numerator, and now I'm left with units of molecules, which is exactly where I'm trying to go. One thing about the math, I know this math looks creepy, but it actually isn't too bad. 1 here times 6.022, 1 times 6.022 is 6.022, isn't it? What about this 10 to the negative 6 times 10 to the 23rd? If I've got 10 to the negative 6 multiplied by 10 to the 23rd, what do? You actually just add these exponents. So 23 plus a negative 6 is equal to 17. So the final answer to this is 6.022 times 10 to the 17 molecules. Yeehaw. Here's another lecture problem. The molecular formula of aspartame, which is also known as NutraSweet, is this. What is the molar mass of aspartame? How many moles are present in 1 mg? How many molecules of aspartame are present in 1 mg? And how many hydrogen atoms are present in 1 mg? And we end with one last problem. At least 25 micrograms of tetrahydrocannabinol, THC, the active ingredient in marijuana, is required to induce intoxication. The molecular formula of THC is C21H30O2. How many moles of THC does 25 micrograms represent? How many molecules? I confess that in reviewing this lecture slide set, I think I might have had too many questions involving illegal narcotics. Hopefully I don't get investigated by legal authorities. With that said, I think it's a wonderful place for us to stop. I hope that you've had a wonderful time and that you stay tuned for our next and concluding lecture on Chapter 3's coverage of stoichiometry and calculations with formulas and equations. Until then, have a wonderful day.